Hey, Nathan here from PH Studios, and welcome back to another tutorial from the Tower Defense Engine series. Last tutorial, we created the tile class and got that all ready for our path and pathfinding classes. Now, in this tutorial, we're going to talk about the pathfinding class. Now, all the pathfinding class is responsible for is having the A-star algorithm in here. Now, this is going to be an incredibly short tutorial, because I'm only going to briefly discuss A-star in general. If you want to get more information, I have a 50-minute video on A-star. If you want to search my YouTube channel, or I will provide a link in the description to the A-star tutorial. Okay, so we do need to have a field, a public list of tiles for the path. Now I'm going to copy in the A-star algorithm and paste it in here. I'm just going to make sure everything's correct. And it looks like we have a tile type that not passable. So let's go ahead and in there, let's change non-passable to not passable. So inside of the tile class, inside the public enumerated tile type, looks like I mistyped with the not passable type. It should be not. N-O-T as in Tom. Alright, so we should be good to go now. Okay, so the pathfinding, the A-star, how the A-star algorithm works is we have a tile start and a tile end. We need to calculate the shortest path from start to end, and we do that by using the adjacency list we have in the tiles and right here. And the way it works is we add a tile to the open list. So the first thing we need to add to the open list is the start tile. Remember, we go from start to end, so we know we will always land on the start tile, so we add that to the open list. Now we have a while loop to determine if the tile L up here, if the L is not equal to the end and the open list has tiles in it, so the open dot count does not equal to 0, so we have a tile in the open list, and the end's parent is equal to null. If all these conditions are true, we will do a while loop every time all these are true. That's what the AND is for. So the tile L references the find best node, and we call the find best node method, and that uses the heuristics I mentioned in the previous video to determine the lowest tile cost. Now my A-star algorithm kind of focuses a little bit more differently than the generic A-star algorithm. I add additional conditions to kind of help the process a little bit more than the basic A-star algorithm handles. So if we are currently looking at the first tile in the open list. And now we need to check every other tile in the open list, and we have a new tile reference here. I just called it N. So N is referencing the ith item in the open list. So we have a for loop, integer I. So we look at the ith item in the open list. Now if the heuristics of the new tile is less than the current lowest tile we have, we need to reset it to the new tile. We need to set lowest to the new tile. This basically needs to find the lowest cost tile and then return at that lowest cost to our main A-star algorithm. So once we find the best node and it does not equal to the end, we need to perform additional tasks here. So we find the best node, it is not equal to the end tile, we need to remove it from the open list and add it to the closed list, and then we need to set its display region to closed. Now for every tile inside of that lowest tile's adjacency list, we need to check to see if it's not passable or if it's already in the closed list. If those two conditions are true, we need to look at the next adjacency tile in the list. It has to be passable, and it cannot be already in the closed list. Okay, if we have a valid tile that we can test with, we then need to check if it's already in the open list. If it's not in the open list, we need to add it to the open list, and we need to set the adjacent parent to our current lowest tile. If it is already in the open list, that means we need to update our distance. We need to check if the new distance is less than the adjacency tile's distance from start. If that's true, we need to change its parent, and we need to set its new distance. So that's a very brief overview on the A-star algorithm. If you need to know more about that, go ahead and check out my 50-minute tutorial. I don't want to make another 50-minute tutorial on an A-star when I already have one. So that was a brief overview on how this algorithm works. So if you want to understand A-star completely, you can check out my video on that. Otherwise, we're ready to start the next class, which is the Path class. So I hope to see you next time.